is show you how the quadratic formula came to be, because it's important for you as honor students and people who will be taking higher level math for you to understand, formulas just don't show up out of nowhere, these shortcuts that we do. There's a reason behind them. So I'm going to show you how we get the quadratic formula from completing the square for the standard form ax squared plus bx plus c equals 0. Now, I would say this. Come along for the ride with me and pay attention and ask questions if you have them. But if at any moment I just lose you a little bit, it's not a big deal. So it's not like I'm going to test you over how to complete the square. I just need to make sure that you can see where it comes from or it's derived from. Okay, yeah. Yeah, definitely. Okay, what would we do first to complete the square for ax squared plus bx plus c equals 0? Move the constant to the other side. So that's going to be ax squared plus bx, and then I would move the c to the other side, so that's going to be equals negative c. Okay, now we discussed on Friday that in order for you to be able to complete the square, it's important that the coefficient to x squared is 1. Do we know what the coefficient to x squared is right now?
A.
It's a. So a could really be anything. So just like we did on Friday, what do we do with those a values? Factor it out. Okay, so let's factor out a on the left. That will leave me with x squared plus, and if I factor a out of b, that's like b divided by a, so I'm going to have b over ax.
Whoa.
Okay. And then leave a little space to complete my square, and I got a negative c over there. So if you factor out a, it's like dividing by a. Now we would want to complete the square because we definitely have 1x squared for whatever a was, right? So if that plus b over a was a number, let's say it was plus 6x, how would you complete the square with the number? But what's the process? What would you do, Liam?
Plus b over 2 squared.
Okay, yes, you're thinking ahead. So just like if the number were 6, what would we do to 6? Divided by 2 and square root. Not square root it, square it. Okay, divided by 2 and square it, or take half of it. So Liam's talking about b over a. We got to take half of it. So I'm actually going to do this in blue over here. Or divide it by 2. So it's now going to be b over 2a. That's just half of b over a. And then we're going to square it, which if you square a quotient, you square the numerator and the denominator. And in the denominator, you have to square the 2 and the a. So this is really b squared over 4a squared. And that's the number that completes my square. So I'm going to put that over there on the right side to complete the square. And we're thinking, well, that doesn't look very nice, but we'll just let it be for right now. Now, I just added something to the left side of my equation, but I need to keep the balance, so I need to add it to the right side. But I have to be careful because I didn't really add b squared over 4a squared. I did whatever a times all of that is, right? So I have to redistribute my a. We did that on Friday. So off to the side here, I'm going to do, what is a times b squared over 4a squared? Well, what can you do with your a's? You can cancel the a in the numerator with one of the a's in the denominator. So what did I really do? I really added b squared over 4a. Okay, so on that right side where I have negative c, I'm going to do a little bit of cleanup. And I'm going to say, like, that is really negative c over 1 plus b squared over 4a. And I would really like to just be able to add those things together, but if they are two fractions, I need common denominators. So what's a good common denominator for 1 and 4a? Probably 4a, right? Whatever that may be. So I'm going to do 4a times the denominator and 4a times the numerator. So that's really, this will be negative 4ac. And then plus b squared all over 4a. But I'm going to use my commutative property. That's really just b squared minus 4ac. Some of you may be like,
So
oh.
this is just showing us where the formula
Yes.
is coming from, right? Like
Yes.
you're not going to be doing that.
I'm not going to ask you to do this.
Hey,
Okay, so on this side it's b squared minus 4ac over 4a. Sorry, I gotta get that right. Over 4a. So I added those two things together, right? And then remember on this side where I completed the square, I still have my a, but my whole reason for writing this trinomial was so it would be a perfect square trinomial that would factor, and the two factors would be exactly the same. So I can write it as the square of a binomial. So now I just have to figure out what is the number that goes in there. So think about how is the number that goes in your set of parentheses related to your middle term? How is that number related to your last term? What's that? B over 2a. How did you get that? Anybody know where Grace got b over 2a from? Lilith?
It looks really similar to the completing the square thing where you have x, b over 2a is still equivalent to c or something like that. I can't remember, but it seems
Okay, think about more like here.
Yeah.
How is b over 2a related to b over a? It's half of it, right? How is b over 2a related to b squared plus, b squared over 4a squared? It's the square root, right? Isn't the number that goes in the parentheses half of the middle term and the square root of the last term? Yeah, so it's going to be b over 2a. Good. It's like that little part in the in-betweens of completing the square. Okay, so next, what would you do to solve? Okay, divide by a. We usually, like, whatever we factored out, we have to divide by that number. Now, because I have a fraction over there on the right side, that b squared minus 4ac over 4a, I don't actually want to do divide by another a. I'm just going to multiply by its reciprocal. So isn't dividing by a the same thing as multiplying by 1 over a? Okay. And that'll be easier over here at the fraction. So I get x plus b over 2a squared equals, and now I just am going to have b squared minus 4ac all over 4a squared. So our next step to solve, square root both sides. And when we square root both sides, we have to add a plus or minus. So that's going to be over here on the left. So we have x plus b over 2a equals plus or minus. Now I am going to do a little bit simplifying again. So it is a property of radicals that I can do the square root of b squared minus 4ac over the square root of 4a squared. I can separate the numerator and the denominator. Now back in like September 20th, 2018, whatever that date was, September 19th, thank you, Avery. These, I told you this was not able to be separated. You can't do the square root of b squared minus the square root of 4ac. That's not a property for plus or minus. But you can do it if things are being multiplied. So in the denominator, what's the square root of 4a squared? 2a. So we're going to get plus or minus the square root of b squared minus 4ac all over 2a. And then our last step is to subtract b over 2a. So minus b over 2a and minus b over 2a. And on this side, it just cancels out, so we have x equals, On the right side, remember, I always put that number in front of my plus or minus. And since they have common denominators, I can go ahead and do the numerator together. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah, that's what I have.
Yeah, that's the quadratic formula.
That's what I got on my paper.
Okay, so the quadratic formula is not just some formula some mathematician pulled out and said, here's a jumble of a's, b's, and c's, and it works, right? They're doing the steps of completing the square to get the solutions. So completing the square and quadratic formula are really the same process. Just one is all in one step. Okay? Okay, so please make sure that you have the quadratic formula written down correctly in your notes. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. What do you mean? Oh, just right. It's right there. It's the quadratic formula. It's exactly what is on the last line. Yep. The quadratic formula was my last line. And we're going to do some song to remember our quadratic formula. I just do the very basic Pop Goes the Weasel. There are some very fancy pop songs that you could YouTube later if you want to look for some fun ways to remember the quadratic formula. Okay. Give me 1 second here. Is there a way on YouTube to make it just keep repeating itself?
Yes. Yeah. Right click it and then.
Right click it? Oh, brilliant. I love it. Thank you. Okay, so I'll model it for you, and then you can join in on the next round. And everybody's lips need to be moving. If you're not singing the quadratic formula, then you got to come up and stand in front of everybody and sing it by yourself. So if you'd rather just do it at your desk, that's fine. What happens in A08 stays in A08. So no one needs to know that you were singing the quadratic formula, okay? It's just something that you do for Ms. Cronky. Okay, so Ms. Cronky will help you out in the beginning. Hope I don't blast you out of the... Equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Join me. Equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Now you try.
Okay, so we're going to do it one more time. Let's hear it. I'm going to sing less. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. High fives, everybody! You did awesome. Yes. Okay, so it's always so adorable when you guys are taking your quizzes and tests and you're humming and singing the quadratic formula. So.
I will do it.
Okay, now we need to put the quadratic formula to use. Okay, so there's an important part of the quadratic formula that's called the discriminant. Make sure you write this down. You'll be asked some questions on your quiz and your test about like find the discriminant and tell how many solutions it has. So the discriminant is the part of the quadratic formula that's underneath the radical. It looks like b squared minus 4ac. And depending on what the value of the discriminant is, you know certain things about your solutions, like how many solutions you'll have and what kind of solutions they'll be. If the discriminant b squared minus 4ac is greater than 0, so a positive number, you will have two real solutions. I have visually what that would mean on the board over here. So yeah, solutions in quadratic equations look like x-intercepts on the graph. So if you have two real x-intercepts, then you'll see a parabola that crosses the graph 2 times on the x-axis. So I think it would be a good idea in your notebooks to maybe draw a quick sketch of what that could look like. It could be a parabola that opens up or down. It could be left or right of the y-axis, but it is going to cross the x-axis 2 times. Okay, so 2 real solutions looks like 2 x-intercepts. Now, the next one is going to be when you have only one real solution. So just think about the quadratic formula, the opposite of b plus or minus the square root of something all over 2a. The only way for you to get one real solution is if you're taking the square root of 0. So that the opposite of b plus or minus 0 is still opposite b. And then over 2a, I only get one answer. So whenever the discriminant is equal to 0, you have one real solution. Now, later on, we may talk about something called multiplicity. And multiplicity is just how many times an answer occurs. So in a quadratic, you have to have 2 solutions. If you get 0 and there's only one real solution, it means it has multiplicity of 2, or that solution appeared twice. That would be like you're graphing a perfect square trinomial, x minus 3 times x minus 3. And the last one, if the discriminant is negative, what kind of answer are you going to get? No real solution, which is what kind of answer now? Imaginary solutions. Okay. So we now know about imaginary solutions. If we put the discriminant to be negative, then we're going to have an I in our answer, and we're going to have 2 imaginary solutions. Oh, in terms of these graphs, if you have 2 imaginary solutions, that's going to look like a parabola that never crosses the x-axis. Could be above, or like over here I have below, never crosses the x-axis. And then one real solution, that must mean you're sitting on the axis, whether you're opening up or down, but you only cross the x-axis 1 time. So you'll have to read your directions very carefully. Like in the next 2 examples, all I want you to do is find the discriminant. So it's the only part of the quadratic formula that you have to do. B squared minus 4ac. So just do b squared minus 4ac and tell me what type and how many solutions you have. So I'm gonna want you to be able to report to me what the discriminant value is. If you need a calculator, go ahead and get that out. List the number and the type of solutions for these 2 quadratics. I'll give you a couple minutes to do that. the x squared's coefficient is a, the x term's coefficient is b, and the constant is c. So this must be ax squared plus bx plus c. They could be out of order, but you would be able to tell what they are based on what they're a coefficient for. So a equals -2, b equals -3, and c equals 5. So go ahead and calculate the discriminant. I want a number answer for the discriminant if I call on you. And tell me how many and what type of solution there are. Yes, sir? So what? Okay, can you give me a more specific question? I'm asking you to calculate the discriminant to determine the number and type of solutions. So the discriminant is b squared minus 4ac. So I just listed up there. A is -2, b is -3, and c is 5. Why don't you write that in your notes?
Oh, that's a both.
And then do b squared minus 4ac. Okay, let's chat. So if I do the work for this first one, b squared minus 4ac, or at least do the setup, I'm doing b, which is -3, quantity squared. Now I usually put that in parentheses because I want to square all of the -3 if I'm doing it in my calculator. I'll need the parentheses. And then -4 times -2 times 5. So Sarah, can you tell me what you got for the discriminant there?
I haven't gotten it.
Oh, okay, then let's do it together. What would you get for -3 squared?
I just get 9i.
9. Okay, and what is -4 times -2 times 5? 40. And is that a positive 40 or a negative 40? I'm asking the whole class. Is that a positive 40 or a negative 40?
Positive.
A positive 40. Okay. So calculating the discriminant should not be a very challenging job. It's just do b squared minus 4ac, right? That's all I'm asking you to do. Now, looking at the discriminant, how many and what type of solutions do you have? 2 real solutions. So that would be underneath, if I wanted to actually find the solutions, at that point I've already done the stuff underneath the quadratic or underneath the radical. So it would be x equals the opposite of b, which would be 3, plus or minus the square root of 49 all over 2 times -2, right? I already did all the work for b squared minus 4ac. I'm saying if I wanted to find the actual solutions. Okay. Now, let's talk about the bottom one. Lilith, what did you get for your discriminant here? -47 is correct. You're doing -3 quantity squared minus 4 times 2 times 7. So you get -47. How many and what kind of solutions do you have? You have 0 real, but you also have 2 imaginary. Okay, so that's something that we're going to need to study for our quiz and our test. How many and what type of solutions do you have based on the discriminant, right? So if I were to actually find the solutions for that one, if I were to do the whole quadratic formula, remember we just did the stuff under the radical, so it would be like x equals the opposite of b, which is positive 3, plus or minus the square root of -47, all over 2 times 2. So what will we do with the square root of -47? We can write that as I, so that's x equals 3 plus or minus I square root 47 all over 4. And that would be our simple answer. On the one above it, if 49 is my discriminant, then I have some more work to do, right? What's the square root of 49? 7. So I would do like 3 plus or minus 7 all over -4. And then I can do 2 problems there because everything's a nice number. I can do 3 plus 7 divided by -4 and 3 minus 7 divided by -4. So this one would be 10 over -4, which is negative 5 halves. And this would be negative 4 over negative 4, which is positive 1. Okay, so those are my two real solutions. Now, if you ever get real solutions like that, where like the discriminant was a perfect square, and you come out with nice numbers, like well rational numbers, like negative 5 halves and 1, that meant that that quadratic could have been factored. Okay, so remember that if given the choice, you can check for factoring first. If it can't be factored, then you would have to choose completing the square or quadratic formula. Okay, let's try one more. I want you to do this one on your own. Can you accurately calculate the quadratic formula? 0 equals x squared plus 4x plus what? I want the solutions. Yep, do the whole quadratic formula. Solve using the quadratic formula. Have a quick chat with your pod members or call me over if you're unsure of where to start. See if you can evaluate this one for me quickly. Okay, how are you doing on this discriminant? You work on this quadratic formula then. Depending on your level of comfort with quadratic formula, you may be writing off to the side what A, B, and C are equal to so that you can just plug them in. Remember that A, B, and C don't have any x's on them. They are the coefficients to the terms. So you're just putting numbers in. Oh, you're solving by completing the square? So I want you to practice the quadratic formula instead today. You forgot to balance your equation. You forgot to add 4 to both sides. That's right.
I don't know what to do.
You need to simplify your radical.
So simplify into like 2 squares or
Yeah, however you would square or simplify it through any class.
I got negative 4 plus or minus 2. Oh yeah, I did.
simplifying rational. You would choose 12, 2, 3, 4, and then 2, 2, or 2 go under the bracket or outside.
Outside. Okay, so I'm going to go through like what I would do to solve and what your final answer should look like for me. So I plugged in the opposite of b, which would be negative 4. Then I have the plus or minus, the square root of b squared minus 4ac. So I put in the 4 squared minus 4 times 1 times 1, all over 2 times a, which would be 2 times 1. Now I usually, and I recommend that you do this, show your work here so that I know how you got the number under your radical. So 4 squared is going to be 16. Whatever b squared is, it's always going to be positive, even if b is negative, because you're going to square it. And then on this one, I have a negative times a positive, so it's still going to be minus. And then 4 times 1 times 1 is 4. So that gives me 12 underneath. And if you have a hard time with that, remember that you could always make that a little easier on yourself by doing b squared minus 4ac off to the side. So if that's something, if you need to kind of separate it and do the discriminant first, and then plug the discriminant in like I did on the last slide, you could do that so that it doesn't look like such a big monster equation. Okay. Now, here's where I want to talk about some of my favorite mistakes that I've seen students make in the past. So a lot of times when students get here, -4 plus or minus square root 12 over 2, they see all even numbers, so they want to simplify. But you're not allowed to divide 12 by 2 because it's under the radical and 2 is not. And that also means that you can't divide just -4 by 2 and make this like -2 plus or minus square root 12 because square root of 12 is also being divided by 2. Okay. So you have to be really careful here. One thing I always recommend is check your radical. Your radical should be simplified as possible. So can you simplify square root 12?
Two radicals.
Yeah, it's the square root of 4 times 3, which is the square root of 4, or 2 square root 3. So that's going to be -4 plus or minus 2 square root 3 over 2. And then I can reevaluate, like, can I reduce all the numbers? Well, now that I have a 2 on the outside there, and it's also even along with -4 and 2, then they can all reduce by 2. So this is really -2 plus or minus the square root of 3. And that would be your final answer. Now, generally, I'll say this. Please leave your answers in exact form. So that would be like with the radical. The only time I would really say like work out the quadratic formula if it has a radical in it would be if it's the answer to like a real world problem. So if it's the question like how many seconds does it take the ball to hit the ground, you probably don't want to know -2 plus the square root of 3 seconds. You want to just evaluate that as a decimal. But of course, like that example where we had the square root of 49, if this was -2 plus or minus 7, then you should write 5 and -9. Like you should simplify those numbers. Does anybody have any questions about that? Also be on the lookout for imaginary solutions. Like I showed you my favorite mistakes in your completing the square concept check. Please don't just drop I from the solution. It should be in the solution. You might have an I in front of a radical. That's fine. Okay, so your homework assignment for tomorrow is on your gold sheet. Before you start the quadratic formula, make sure that one side is set equal to 0 so that you get the correct signs for A, B, and C. Does anybody have any big questions from the homework assignment from Friday that you want to address going into tomorrow? You do have a short quiz at the end of class tomorrow. Okay, if there 5, 7, 9, 11.
No,
25 is not required. So I'll put up a couple of the first ones so that if you want to get started, you're using the quadratic formula to solve these. So see if you can do a couple before you leave. X squared minus 4x plus 3 equals 0. X squared plus 6x plus 15 equals 0. And I'll put up number 9. X squared minus 14x equals -49. So that number 9 is a good one for you to look at. Like, make sure you move 49 to the other side before you do the quadratic formula.